In this project, we're going to deploy MySQL using AWS's fully managed database services. We'll walk through setting up both Amazon RDS for MySQL and Amazon Aurora MySQL compatible edition. These options allow you to deploy, scale, and operate MySQL databases without managing the underlying infrastructure yourself. These are considered platform as a service features from Amazon. We'll start by provisioning an Amazon RDS instance. You'll learn how to configure storage, networking, and security groups to create a MySQL environment. We'll also cover how to recreate read replicas to improve performance and availability. Next, we'll explore Aurora MySQL. You will see how Aurora differs from traditional RDS with its distributed storage architecture, automatic scaling, high availability, and serverless features. We'll demonstrate deploying an Aurora cluster with a writer instance and a reader instance, and we'll briefly get into how failover works. To make it easy to manage and inspect your database, we also deploy phpMyAdmin using containers and AWS App Runner. This provides you a fully managed web interface for connecting to both the RDS instance and the Aurora cluster we'll build, so you can run queries, browse tables, and monitor your databases right from your browser without needing to set up any additional servers. As a part of this project, we're also going to deploy the Sakila sample database. I hope I'm pronouncing that right. This model is a fictional DVD rental store. It's a well-known database. You can Google it. You can ask ChatGPT about it. It'll tell you all about it, but we're going to do some simple queries, and it's, a fairly involved database with foreign keys that you can do joins on. Along the way, we're going to use Terraform and shell scripting to automate the infrastructure deployment, following best practices for security, scalability, and repeatability. You'll get step-by-step examples you can adapt for your own projects. By the end of this project, you're going to have a clear understanding between what RDS MySQL and Aurora MySQL offers, and you'll be able to choose the right option for your workload. Spoiler alert, it is probably going to be Aurora. By the end of this project, you'll have a complete working environment you can adapt for your own use. Okay. Now let's go over the architecture diagram for this project. First off, it's in US East 2, and the first thing we do is we create a VPC to host our databases, and in that VPC we have two subnets, subnet 1, subnet 2. Everything is public in this project, which is not ideal for production works, but it's good for learning. So in the first subnet, we're going to have the Aurora MySQL instance writer, and then we're also going to have the MySQL RDS instance, the main instance. In the second subnet, what we're going to do is deploy the Aurora MySQL reader, and then after that, we're going to have the RDS read replica. So those are the four instances that you'll see deployed when we get in the console. Now, what we also do is when we provision the databases, we need a credentials to log in, the admin credentials. And what we're going to do is generate a random credential, put it in Secrets Manager, so you have Aurora Secrets and you have MySQL Secrets. And finally, this is sort of a twist compared to our Postgres one, is we are deploying phpMyAdmin, which is a pretty well-known admin tool for interacting with MySQL. It's a web-based application. So what we do is we create an instance, a public instance of this, which is available in the Amazon public repositories, put it in App Runner, and then configure it with the environment variables to our databases. And then you can log into each one from the web. All right, let's compare the differences between RDS for MySQL and Aurora MySQL. Now, the RDS for MySQL instances, the best way to conceive of that is it's a platform as a service. But I'm pretty sure what Amazon is doing behind the scenes is deploying an EC2, installing the software, configuring it, configuring backups, patching the OS. So you can really think of it as an Amazon managed EC2 for you. It's kind of similar to Active Directory. That clearly is managing EC2 on your behalf. It's the same way with Amazon RDS for MySQL. Aurora is a little bit different. I don't really know what they're doing. I have a guess that it's probably container-based because how it is better designed for distributed storage, scalability, and multiple reader writers. And so let's talk about a couple of the key differences in this. I'm not going to go all of them, but let's talk about probably the top three. Performance. MySQL RDS is it's basically that one EC2. So you're limited by EBS and single instances. So you can have a reader, but it is sort of an old school type of deployment. Now, Amazon Aurora MySQL is designed for 5x the throughput. It has the ability to scale horizontally in addition to vertically. RDS for MySQL, you mostly scale vertically. You get bigger instance types. Now, when we look into the console, we'll see sort of the descriptions to the Amazon RDS for MySQL, and you'll see a lot of things that kind of feel like EC2s. They're a little bit abstracted. Then we have high availability and replication. This is probably the biggest difference between the two. An RDS for MySQL, you can have up to 5 readers. Those read replicas, and those read replicas are asynchronous. When you do a write, you're not necessarily guaranteed that it's going to be immediately available. It's more of a eventual consistency. It's not long, but it's not guaranteed to be synchronous. Compare that with Aurora readers. They can have 15 of them in addition to the 5, so you get 15 more. And then what you can do is it's all synchronous. It's more like ACID instead of eventual consistency. Now, there is a little bit of exception if it's replicating or reading to another region. I think there is a possibility of a delay, but within the same region and the same availability zone kind of setup, it's all going to be, synchronous. Then I guess that's the availability and performance. We'll kind of show you that a little bit when we demo. The cost, that's probably another bigger thing, is the cost for Aurora, since it offers a lot more features, is more expensive. It is nice that you can have serverless, so you can start off with serverless at really low and then scale up. So that is interesting that you can start cheap, but once you get to a full load, in general, Aurora is going to be a little more expensive than RDS. And as far as features and compatibility, I mean, Amazon Aurora MySQL is an implementation by Amazon. It supports Postgres and MySQL. We're going to do the MySQL version here. But there are some, if you're using an advanced or an esoteric feature of MySQL, it's possible it won't have been implemented inside of Aurora yet. So if you need really advanced features, then maybe you need to go to that. So what is the right service? If you need a cost-effective, fully compatible MySQL just for kind of standard workloads, RDS is probably the way to go. It'll be a bit cheaper, but you don't scale as well. If you're a high-performance application and you need global replication and all the bells and whistles at Aurora, which most of the time you do need if you're going to build a big application. Okay, now let's talk about the prerequisites needed for this project. The first thing you need is you're going to need an AWS account. And in that AWS account, you need a secret and access key. We have a video for setting all that stuff up. The AWS and Terraform easy setup should be linked up above here. Then we also need the AWS CLI, and that's because of the shell scripting that we use as part of the build. Then we also need the latest Terraform. And then to load the Sakila database, you're going to use the MySQL client commands. So that's the command to install an Ubuntu, but it's available everywhere. It's a pretty ubiquitous client on most platforms. All right, so to build the project, the first thing we want to do is we want to copy this GitHub link here, and let's go to your Ubuntu development environment and paste that in. So the first thing you want to do on our projects is you want to run check env, and that is going to make sure that all those prerequisites that we talked about, the access key, the secret, Terraform, AWS, MySQL, that they're all installed. So this gives you a good feel that you've met all the requirements. So at this point, what you want to do is run apply. Now, apply, it takes approximately 30 minutes to build this project. Okay, the build has completed. So what we're going to do is go into the console and take a look to see what got built. So here's the console. So you want to go up at the top, you can say Aurora, and it should say Aurora RDS. So you click on that. And here we've got 4 instances deployed. A Aurora MySQL instance writer, instance reader, and then the MySQL instance with RDS with its replica. So let's drill into the Aurora SQL cluster. So the first thing you'll notice is you've got these different endpoints. So this is the writer endpoint, and then this is the reader endpoint. Now we've talked about how you can have 15 readers. The way it works is this reader endpoint is the same, and it's a load balances between your reader and instances. Then it handles your backups and maintenance. Then we get into the readers and writer. So we'll click on the writers, and let's go back to connectivity. Configuration is actually what I want to look at. And this is where you can see that it's defined for serverless mode. And the way you do it is you specify a number of ACUs, which is Aurora capacity units, and this is 0.5 to 4. Now you have to be very careful with these to make sure you have the right values, because it gets wonky when you exceed it. It basically gets throttled. It doesn't fail, so you'll get stuck. Some queries will start failing. They'll take too long. They'll time out. And it's kind of a head scratcher until you realize, oh, I don't have enough capacity units. So it's easy to change. You can change it on the fly. You can go up, you can go down. But if you ever experience an Aurora situation where it's wonky, you know, that it's timing out, check your serverless and Aurora capacity units to make sure. So that we have the reader and writer, and we've talked about how the reader is synchronous. So as soon as you do a write, it's available on the reader. There's no lag. It's an ACID compliant type of solution. And we've got this notion of you've got the reader and writer. Now I can go back into the cluster and I can click on my writer, actually my reader, this guy right here, and I can say failover. And what failover is going to do effectively is you're saying this instance is bad. Go and promote one of the pending readers into writers so that it will not be servers. So I'm doing failover, and I click failover. And effectively what we're going to do here, since we only have one, it's just going to swap. After it finishes, it'll just swap. Okay, now you'll see the reader and writer swapped, which, wasn't a big deal. And really, for failover, what I just did, you would almost never do, because there are CloudWatch alarms installed on all these instances. And if AWS detects, hey, this writer's bad, it'll automatically failover. The only scenario I've seen where you do a manual failover is if you're trying to failover to another region. I don't think it does that automatically, but generally in the same region, if you have 15 readers and one writer, and the writer fails, it's just going to promote one of those writers or one of those readers to writers, and you're good to go. So that's a neat little feature of how it automatically fails over. So that's it for Aurora, the configuration. Now let's go back to the databases. And let's look at MySQL RDS instance. So you click on that, and you've got the same networking as the other ones, but really what we want to look at is the configuration. And this is where the theory that this is really just an EC2 is kind of the basis of that theory. Because you've got an instance class, so that's like an EC instance type. You got the number of CPUs, the RAM, you've got the storage, the IOPS, the storage throughput. These all look to me like EC2 options, like you're basically specifying the parameters for the EC2 that's going to be provisioned that has MySQL installed on it. It also has maintenance and backups, just like the other ones. It all handles that for you as a platform as a service. And I guess the last thing to talk about before we do the demo is let's talk about promoting this replica. So I'm going to go here and I'm going to say that, and I'm going to say promote. And it's going to say, all right, I'm going to choose no automated backups, and I'm going to promote the read replica. And so you're going to see it update here. And when it's done, what you're going to get is this MySQL replica is going to be a peer or a sibling of the main instance. They're now totally disconnected. So when you promote it, it's actually making this a reader as a backup at the time that you did the promotion. So at that point, they're completely independent. You can start using them separately. So it's a very different kind of DR scenario and strategy you would do here, where you promote a reader and then it's now you have to have these two different instances and figure out how to reconcile them. So I think it's really neat how Aurora handles this failover and read promotion. That's what I call the failover essentially. Is solving the same problem of if something wrong, I need to promote to the next one. I think it also works a lot better in Aurora with failover than this whole replica thing. So we'll wait for it to finish so we can see that this is a fully modified peer before we move on to the demo. Okay, now it's completed. You see you've got that replica is now promoted to a full instance. These are both read-write, and right now they're equal, but as soon as I make any changes, they're totally going to be totally out of sync. So that's how the read replica promotion works with RDS. Again, I think it's a lot more robust with failover in MySQL Aurora. So let's cover the Secrets Manager. So when I built these databases, I created a random password and put that password in secrets. So for like Aurora, I can go in here and I can say retrieve secret value, and you'll see it's got the endpoint and then the user ID and password. So what I'm going to do is open a new tab because I'm going to need that later. So the last thing we're going to show is for what we deployed is I'm going to do app runner. And this is where we have that phpMyAdmin web app interface that we have deployed using the simplest container runtime. Now there is a video out there, AWS Simple Containers, which covers App Runner. This is just one use case. So if I go and click on the RDS, what you'll see is you'll see I'm using the source public phpMyAdmin, and then we need to configure it. And so if I go and look at configuration, you'll see there's a bunch of, actually it's just the endpoint that's put in there. So there's the PMA host environment variables. That's all you got to do is you do the container and say, here's the database to connect to. And so what you're going to end up to is you're going to have these two different endpoints. One's connected to RDS, one's connected to Aurora. Okay, what we need to do is we can go back to, let's just use this one right here. I'm going to open this guy right here, connect to the RDS instance. So I'll click here, and it's going to open up the phpMyAdmin page. Now this was the RDS one, so I'm going to go back to secrets, and I'm going to click on MySQL credentials, which is the RDS version. We do receipt. The password's always admin for this deployment, so I'm going to copy this password, and I'm going to go into here, admin, and click on login. So this is the phpMyAdmin interface. We've got the Sakila database here. We've got the tables, which is a bunch of movies and actors. So you can say, all right, let me look at this guy right here. And you can see a bunch of actors with random names. None of these are real. And then we have film. And I have a film. And so the other thing I can do is I've got, these all have foreign keys. You can see, where is the key? Film ID, and then there's an actor ID. So what I can do is I can go to SQL here, and I'm going to go back to the documentation, and I've got some fairly non-trivial but not too complicated joins. So I'm going to take this guy right here. I'm going to say copy that. I'm going to put it into here, and I'm going to say paste that in there, and go. And it's going to go and list all the actors and the movie they're in. So it does a join of a couple of tables to get this information. So that's it for the MySQL RDS instance. I'm going to do the same thing with the Aurora instance. So I'll click on that. And then I'm going to go back to Secrets Manager, click on Aurora, and I'm going to go and retrieve value. Password is that. Go back to this guy right here, say admin, paste this in, and we have the exact same database. So we've looked at the tables. Let's go to SQL, and I've got one additional query to run, which is right here. Let's put that into the query, hit go, and you see it does it a little bit different. And it does the movies, and then it does a comma separated list of all the Rock Tukaks. These are pretty funny names when you start reading them. All of the actor names in a single movie. So it's just a different way of doing the joins. Again, they're not too terribly complicated, but that's pretty much it for the demo. At this point, you want to be a good steward of your cloud account, and let's close these here, and let's go back to our database here, and let's run destroy. Now, destroy takes about 10 minutes to run.